Hello everybody, this is Arvindan Ashokan, the Senior Project Manager from Indium Software. Today we are going to see one of our mature frameworks called iSAFE, which was originally developed as a Selenium framework. Later we integrated a whole lot of tools which enables the framework now to automate even Flash applications or mobile applications. So here is the agenda, compact and simple. We'll be seeing the architecture of the framework, a little bit about the features, the Selenium grid, which is the main component behind our framework, and a demo of our framework. Here's the high-level architecture of our framework. So we have the driver script, which is responsible for kicking off the execution, and everything that we are talking about is built on core Java. So we will never be stuck up with the limitations of a particular tool. Rather, we can live up to the capabilities of Java. If there is a requirement to read the PDF and validate something in a PDF file, we're not stuck up. So all we have to do is identify the appropriate jar, add that particular jar in the framework, and start coding. So everything is built on Java. And the driver script is responsible for coordinating between the various components of the framework. So we have a common libraries, which is a very high-level, library files which are specific for generic needs. Instead of confusing, let me give a couple of examples. For reading and writing to Excel spreadsheets, we use a utility called JXL. So that's available in our common library. For sending out an email at the end of execution, we use a utility called mailer and activation. So all these things are part of our common libraries. And the automation script is built using our generic keywords. So by generic keyword, what I mean is we have framework-defined keywords that can be used in our scripts. For example, open browser could be a keyword. Navigate to a particular URL, that could be a generic keyword. If we have to click on a button, we have a keyword called click on something. So we have to select from a drop-down, we use a keyword called select from drop-down. So all these are generic libraries. The object repository is a term that we adopted from the tool called QTP. So where we store or where we isolate all the page objects or the UI elements are saved in a separate location called object repository. So if there is a change in the UI, all we have to do is just get into this particular location, update the properties of a particular element whenever there is a change in the UI. So we separate out the UI components and store it in the object repository. And the generic libraries picks up the object from object repository, and we create some keywords which are used in our automation scripts. Again, there is a input data part of it where we have the suite level data we provide, or the test case level data for execution, whether we need to execute a particular test case or not. And also we have a separate spreadsheet for maintaining the test data. So the test data is again separated out of the script. So whenever there's a need to execute a particular set with multiple sets of data, we don't have to replicate the script. So we can use the same script, we can call the script with multiple sets of data. So when we see the test data sheet, we'll understand better. Just moving on to the other features, we have a reporting engine which is capable of creating the reports in multiple formats. We use XSLT for transforming the XML into multiple formats. And we have a command line utility which is easy to be tied to any of the schedulers. To be a Windows scheduler, we can tie it up to trigger the execution every night or every week or month, or even we can tie the commanding ability to our tools like Jenkins, Hudson for continuous integration testing. So this is the high level architecture of our framework, and moving on to the features of the framework. As I said, the framework has capabilities of creating reports in multiple formats, and we get exhaustive log. In fact, every step that gets executed in the framework is recorded in the log. We have support for any type of mobile applications, um, be it a native application or a web application or a hybrid application. So it supports all these applications because we have Appium integrated in the framework, which takes care of it. And whenever there's an exception or a failure in the test cases, the framework can capture the screenshot of the failure screen and add it in the report. Or if there's a need to capture the screenshot of the application for auditing purpose or for manual verification, that is possible. One of the most important feature of our framework is target-based execution using Selenium Grid. So we'll be seeing in-depth work, in detail about the Selenium Grid in the next slide. So I'm skipping that for now. So we have spreadsheets, as I said, for the suite, for the test case and test data level. So the three different configuration sheets are available. So whoever has to execute the test cases need not know scripting. All they have to do is just open these three files, make the necessary settings, save the files, kick off the execution, and they're going to get the results in their inbox. So the framework also has support for Flash applications. We have integrated a tool called Genie for achieving this purpose, and the framework also supports multiple operating systems. Pretty much, any flavor of Linux, Mac, or Windows. All these platforms are supported, and in fact, any browser that has support for JavaScript. And last feature that I would like to highlight is at the end of the execution, you don't have to go to a particular folder to check the results. What the framework does is it bundles up everything, zips up everything, and sends out an email at the end of execution, which will reach out to all the stakeholders. And alternatively, it can also send out SMS text messages or make voice calls to the stakeholders. So all these things are possible in the framework. This slide talks about the Selenium Grid, which is a key component of our framework. So the main concept behind the Selenium Grid is we have all the scripts available on one location called the hub machine, and we execute the scripts on multiple target machines called as node machines. So the main point to be noted here is the scripts are not available on any of the target or node machines. So it's just available at one location called hub, and it can be executed on any of the platforms like Windows, Linux, or Mac, or Android device, or iOS device, or even on the cloud-based services like Sauce Labs or Browser Stack, etc. So, with that introduction about the framework, we are moving on to the demonstration of the framework. First of all, I would like to show you the configuration files that I was talking about. So let me open up the first file, please. Okay, this is the first file which is used for setting up the suite level data. So, so the application URL, the username, password, all those information, and we can also have different types of timeout that we can set. For example, the QA environment may not be as fast as the prod environment. So in that case, we can have lesser timeouts for the prod environment against the QA environment. Some environments may be faster, some may not be. So we can have a different set of um, you know wait times for each of these applications, each of these environments. So we also have this particular section here. Most of the information is masked just to maintain the privacy. So we have hard coded these in our script currently, but it actually picks up the values from here. So we also have the database configuration where we can provide the DB path, the username, password, and connect to a database, execute a query, retrieve a record set, and based on the record set, we can validate some stuff on the UI or on the backend. So all these are available in the framework. And moving on to the next sheet, which is the test case configuration, where we mark the test cases for execution. So when it's marked as yes, it gets executed. If we say no, that particular test case doesn't get executed. So little bit about the application that we're going to demonstrate now. It's just a demo application. It's a flight reservation application where we'll be seeing a login scenario and a flight reservation and a logo. So just to show the difference between pass and fail, we have an invalid login added in the scenario. So invalid login actually fails. So just to show the difference in the report, we have included an invalid or a failure scenario. And the best part about the execution is it's going to happen on multiple platforms parallel. So even before I show that, I would like to walk you through one more sheet, which is a test data sheet. So each of the test cases that we have picks up the data from this particular sheet. So whenever there is a need to change the test data, we don't have to get into the script and change the data. All we have to do is just open this particular sheet, make the changes, save this file. So the driver script actually picks up everything based on the information we provide in these three sheets. And I'm going to show you one more sheet here, which is our grid configuration. So this is our grid configuration. We're going to execute 4 different target missions at the same time. So we're going to have the same 4 scenarios that gets executed on 4 different target missions parallelly. And we're going to see the results after it's all executed. So as you can see, the first one is a Samsung Galaxy S4 device. Second one is a desktop mission where we're going to execute the scripts on Internet Explorer. And the third one is an iPad, and we are going to execute the test cases on Review app for iPad. And the fourth one is a cloud-based service called Browser Stack. So we're going to execute the scripts on Browser Stack, and we're going to use Windows XP operating system and Firefox 30 for that. And again, we have enabled all the 4 target missions here. So it gets executed on all the 4 missions at the same time. So let me show you some stuff here real quick. I have connected 2 different node machines here. The very first one is also our host machine. So we're going to kick off the execution on this machine where we have the Android Galaxy tab connected here. So, and the second session is this is going to be a desktop machine where we're going to have the execution on Internet Explorer. And the third one is going to be a Mac machine where we have an iPad connected. Views reflected to project the screen on the iPad. So the final one is browser stack. This is the browser stack session where we'll be seeing what the execution status is. So we're going to kick off the execution from our host machine now. So just give me a moment here. We are kicking off the execution here. So it just kicked off the execution on the Android. So we can see the browser getting launched here, and okay, it's real quick on this particular machine, which is our desktop machine. It's getting executed on Internet Explorer, so it's quite fast. It's just doing everything in a jiffy. So again, on iPad, it has executed. It has launched the browser, and let me move on. It has also launched the session here. So Firefox 30 on Windows XP, and it's fetching the information about the session. So it's pretty slow on the cloud-based services, obviously because of the latency we have, and definitely it's going to be much faster on the desktop. So I think the execution is already complete here. So this is the Android, so it's getting executed. Let me try to zoom in a bit. Okay, and we have the iPad here. And it's executing on the iPad. Okay, so it's responding now, so it's getting executed here. So the execution is complete on the desktop machine. I'm closing the session. So it's still executing on the Android. Let's see what's happening on the browser tab. It's still executing. The iPad, the execution is complete. I'm going to close this as well. It's still executing on the Android. I think the execution is complete here. Yeah, we got the message. Script execution is complete. So it has closed the browsers on all the platforms, and I'm sure it has completed the browser stack as well. Okay, so what I'm waiting for is an email from our automated reporting engine. So let me quickly go refresh. It may take a couple of minutes. So it has an attachment. So okay, so we've got the email from iSAFE automation here. So this is a summary of our results. So we had 4 target machines, and each of these failed. I mean, one of the test cases has failed in all the cloud because we had this include the invalid scenario included. So because of which we have 25% failure. So let me do one thing. Let me open up. So what we see is a timestamp folder. So for every execution, what it does is it creates a timestamp like this. It's basically the year, month, day, hour, minute, second, AM or PM. All right. So I'm just extracting everything onto my C drive. Open it from the C drive. Okay, so this is the folder. When I open the timestamp folder, we get to see all these different subfolders. This is the exhaustive log I was talking about. So it provides information about everything that happened during the execution. So everything is recorded in here. And we have subfolders for each of the main folders. So first one is the cloud. So let me open that. And we have what's called as cover page, which is more of a high level report. We see it took almost like 3 minutes and 4 seconds executing on the cloud. So we had 4 executed, 3 passed, 1 failed. When I go on to the next level, which is our summary report, we get to see what happened at each test case level. So each of the test cases, okay, one failed. When I drill down to the failure test case, I see, okay, username password was incorrect, so it failed. It could not log in. So so it adds a snapshot here. When you click on the snapshot, it opens up bigger. So let me open the next set of folders. So we also can see the time difference each of the operating system. So we pretty much have identical folder structure for each of the platform. So it took just 32 seconds when we executed on desktop Windows. And it took 2 minutes and 1 second when we executed it on iPad. And Android, it took, this one got executed in 2 minutes and 28 seconds. That's all I had for you folks. Thank you so much for watching this video. If you have any questions, you can reach out to the information provided below, or you can contact us at sales@indiansoft.com. Thank you.